Example 3. A fire is spotted due east of lookout A. Lookout B, which happens to be 8 miles due south of lookout A, sees the fire at north 42 degrees east. How far is the fire from lookout A? Well, let's first start with the drawing. So we're given two sides here, and it says a fire is spotted due east of lookout A. So if I draw one of these lines, if you go due east, that's to the right, you'll see a fire. So here's the fire due east of lookout A. And I'm just going to put an A there for lookout A, right there. Now it says lookout B, which happens to be 8 miles south of lookout A. So now I want to put on a line here. Lookout B is 8 miles south of lookout B. Or of lookout A. So that's 8 miles there. Now, it says lookout B sees the fire at north 42 degrees east. So I'll add that in there. So this angle from north 42 degrees to the east spots the fire. So this angle right here should be from the north 42 degrees this direction. Because again, this is north, this direction's east, this direction's south, and this way would be west over here. How far is the fire from lookout A? So I'm looking for this piece right there. So one thing we can a lot of times do is law of sines, and I'm going to try to do that here because I have a right angle. Honestly, I wouldn't have to do law of sines. I could use psi y cos x, tangent is y over x, because I have a right triangle, and I can easily solve for this angle just by going over to my calculator and discovering how many, there's 180 degrees in every single triangle, and so if I took away the 90 for the right angle, and I also took away the 42, I get 48 degrees, and I can use psi y cos x to solve this. I knew this was 90 because this is due south, and this is due east, so it's a 90-degree angle there. And so for using psi y cos x, you always put your unknown on top, which the unknown is an x, and I'm given the y value here of 8, so I want my unknown on top. Well, that's cotangent. Cotangent is x over 8, or x over y, I'm sorry. So I could say cotangent, and you choose the angle next to the x-axis, which is 48 degrees, will equal my unknown x over my known y, which is 8. And I'm one step away from solving this, as I just multiply by 8. And this should give us our answer. So I'll come over here and type in 8 cotangent 48 degrees. I'm going to hit the degree button just to make sure I get the right answer from the calculator. I hit enter. It says it's going to be 7.2 miles. I'm going to round this, so approximately 7.2 miles. And that should be our answer. Now I'm going to check it real quick by showing you how we could do this with the law sines. What you could do with the law sines is once you have a completed set, you could say that sine, and I'm getting this from the formula chart, by the way, the law sines here, using this formula, is I'll say that sine of 48 degrees over its completed set, which is a crossover here of 8, will equal, and since I'm looking for this x, I'll use this completed set here, sine of 42 degrees over x. Now you could cross multiply and divide. Since I'm just checking this, I'm going to use insolve, which is many 3, 1. I have that fraction of sine of 48 degrees over 8, and that's going to equal sine of 42 degrees and that's going to be over x. We'll do comma x on the outside, like that. Hit enter. Notice I get the exact same answer, so we did do this correctly. Now let's try part B. Ship X is spotted due west of a lighthouse. So again, I'll just draw this time as we go. There's a ship, and it's west of the lighthouse. So if this is ship X, to the west, ship X is to the west of the lighthouse. So that means it's to the left. The lighthouse would be over here. Okay, and so ship Y, which happens to be directly south of ship X, so let's go over here, directly south is ship Y, is spotted south 17 degrees west. And this just needs to be from the lighthouse. So I'm going to go from the lighthouse, south 17 degrees west this way. If ship X is 16 miles from the coast, which would be the lighthouse, how far apart are the two ships? So this time we're looking for this value. And I forgot to write this on there. This is south 17 degrees west. No, south 17 degrees west. We go from this way. So we have 17 degrees there. This would be south 17 degrees to the west using the northeast southwest system. Okay, so here's our problem. So we want to solve for this. Again, we have a right angle. So as long as we can find this angle inside the triangle, we could use psi y cos x, which we could. You just take 90 and you subtract it from 17, and we discover this is 73 degrees right there. And now this one would have to be 17 as well, since that's all that's left over to be the other 90, since that's 90 there. So now I could solve again. I'm looking this time for a y, and I'm given the x. So this time I'll use tangent because you want the unknown on top. And tangent is y over x, so I'll say tangent of 73 degrees, because that's the angle on the x-axis, is equal to the unknown y over the known x, which is 16. Again, we have one step. You multiply by 16, and this should give us our answer. So we'll come back over here, and we'll say 16 times tangent of 73 degrees is 52.33. And so that's what we're getting our y to equal. And I'm just going to say 52.3 miles. Since I'm rounding, I'll do approximately. And this would be my answer here. Again, if you wanted to, you could check it with law signs, where you would use a completed set. So this is our completed set. And you would set it equal to the unknown set, like that. And so you could do a law of signs and say that sine of 17 degrees over 16 equals sine of 73 degrees over your y. And you could solve that. You should get the same answer. Now I have one for you to try.